Okay, so someone asked in class on Friday about coefficients of friction when we were making our tables that we will use this week. Um, how did they figure this out? And I said, well, they have force meters that they've used in controlled situations in lab. So let's take a minute and let's look at these experimental results that were actually achieved through experimentation and see what do they show us. They actually show the magnitude of a frictional force, and that's any kind of a frictional force, is proportional to the magnitude of the normal force. And remember, the normal force, Fn, is equal in magnitude but opposite in direction to weight of the object. So we found that it's a proportional relationship. The greater the normal force, the greater the frictional force is going to be, which is one of the things that we talked about when we talked about what are the two things that cause friction. The first one that several of you answered was the weight of the object. And directly that is true because the weight of the object is what determines the normal force on the object. So when I look at this, I can say that the frictional force is proportional to the normal force, and that the normal force is proportional to or indirectly equal to the force of weight, or we know we often write that as Fg. And when we're talking about this, we would actually be talking about static friction max here. And this is Fs max as well. Because we're comparing the normal force to the frictional force as the object is stationary. Now, when we look at this, when we're talking about kinetic friction, we have to think about things too. I would say the forces of kinetic friction Fk are different. Because the force of kinetic friction also depends on the composition and qualities of the surfaces in contact. So that's where my type of surface really comes into play. Is it present when I'm talking about static friction? Absolutely. Is it important when I'm figuring out maximum static friction and what force is taken to start motion? Absolutely, but it becomes into play even more when the object begins to move, when the kinetic friction is present. So, to express the relationship I'm going to say between frictional forces and the properties of different surfaces we look at the relationship between the normal force and the type of frictional force present. Whether that be F, F, S max or F sub F K. So we look at the relationship between those two surfaces. And there's a symbol that represents that relationship, and we've seen the symbol before. The symbol that represents the relationship between the surfaces, I showed you on Friday, it's mu, which is a Greek letter, and it is called the coefficient of friction. Now, we talked briefly about coefficients of friction on Friday, and we made our list of various bunches of different types of surfaces that might come up in problems. There are two types of coefficients of friction. The first one is mu sub s, and this is the coefficient of static friction. So mu sub s represents the coefficient of static friction. And when I write this in a formula to use it mathematically, it looks like this. Mu s is equal to Fs max over Fn. So I have three different variables here. The coefficient of friction is equal to the force of static friction at its maximum over the normal force. If I look at this, I have mu s is equal to Fs max over Fn, and if I think about it in terms of units on the coefficient of friction, Fs max is a force, so it's going to be in newtons. Fn is a force, so it's going to be in newtons. I have newtons over newtons, hence they cancel each other out, so I can say that the coefficient of friction, static friction, is a unitless measure. It's a ratio of comparison of forces present. So this is what happens when I have a stationary situation. Now, if I have a situation where my object is actually moving, then I have to think about what we call mu k, which equals the coefficient of kinetic friction. Again, it is unitless. It is a ratio of comparison of forces. And it looks like this. Mu k is equal to Fk over Fn. And remember, this Fn is equal but opposite Fg, so it's actually equal to negative W equals mg. So it is the opposite of the weight. Now when I look at this mu k and I look at mu s, I can say that the standard values let's say the standard values of coefficient of friction for surfaces generally range from 0.01 to 1.5. Again, unitless. The other thing when we think about these things, and we talked about this already, Fk is always less than Fs, which leads me to say if Fk is always less than Fs, then mu k is less than mu s. That just should make sense. If I look at my coefficient of friction, if I look at a mu friction with a value of, say, 1.0, it indicates, or it would tell me, the force of friction is equal to the normal force. My numbers for Fs max and Fn would be equivalent because you're dividing through by it, which is going to give you a 1. So I can say that in this case, the external force is equal in magnitude to Fs. That's the only way I'm going to get a 1 as a value for the coefficient of friction. That is when mu equals 1. Now let's look at another situation. Let's say mu equals 1.5. And remember, my formula is mu equals the frictional force over the normal force. Whether this is Fs or K, doesn't matter. The formula is set up the same way. It means, this tells me, this means, or if I think it through, means you would have to exert a force 1.5 times greater than the normal force to cause motion. That's some pretty high friction. The lower the value of mu, the lower the friction. The higher the value of mu, the higher the friction. So let's look at a problem using these formulas. Let's say I have a 24 kilogram crate initially at rest on a horizontal surface. That's important. If it were at an angle, we would have to take that into consideration. So it's on a horizontal surface, and it requires 75 newtons of force to set it in motion. So now I know what my mass of my object is, and I know how much force I need to apply to get it to move. Then I could say to you, find the coefficient of static friction between the floor and the crate. So I'm asking you now to apply one of the formulas that we've talked about. So let's look at, what do I know? I know what my force of maximum static friction is, because that's what it requires to set it in motion. So I've got F(S) max equals 75 newtons. I'm being asked to find my coefficient of static friction, mu s. And I also know that my mass is equal to 24 kilograms. Now, if you remember, we know that weight is equal to mass times gravity, and that the normal force is opposite the weight. So the first thing I want to do is calculate W using W equals mg, which gives me 24 kilograms times negative 9.81 meters per second squared, which gives me a value of, let's see, I gotta grab a calculator, guys, sorry. (24) times negative 9.81 gives me negative 235.4 newtons, and I'm really only supposed to have 2 sig figs, so I'm going to make this negative 235 newtons, and my Fn is equal but opposite, so that would make it 235 newtons. So let's write that over there. Fn equals 235 newtons. So I'm going to carry this over. I'm trying to find mu s, which is equal to F sub s max over Fn. So I want to know mu s. I know Fs max is 75 newtons. I know my Fn is equal to 235 newtons. And I can plug those things in and I can find my coefficient of friction. So I will have 75 newtons over 235 newtons, 235 newtons. So my mu s is equal to 0.32. Again, no units because they cancel out. So my coefficient of static friction is 0.32. I could go back then and ask you to figure out what is this surface made of, and you would use your card and you would figure out what is 0.32 close to on your card. I don't even know. I don't know if that's one that we put on your card. It could. Probably the closest thing is I pull out the one that I used when I gave you guys this. Closest one to 0.32 would be, if I look at mu start, the 0.25 to 0.5, which is wood on wood. So I would have to say, if I were being asked to use the list that you have and what the surfaces most likely are, I would say wood on wood. Now generally, when you do the math, they'll work out just a little bit closer to something. I could say to you, is this a very rough surface? You should be able to say that it's not very rough. The higher the amount of roughness, or the higher the degree of friction, the greater this number will be. Remember, we looked at the one that was 1.5. That would be considered a very rough surface. So when I look at these things, I have to be able to not just do the math, but to look at all the possible outcomes and how that math can be applied to answer other questions. So at this time, you're going to use your handout that you were given. It says friction handout 1. I want you to do number 1, number 5, and number 6, as well as the additional questions that I've left you for today. Those will all be due tomorrow, which is 2/18/26. They'll be due at the beginning of class. If you have questions, come see me in the morning. Barring any unforeseen difficulties, I should be back tomorrow, and we should be in lab. So have a great day, and I will see you tomorrow.